So we changed the schedule a little bit. I'll try to remember to do that on plan book. We'll continue talking about properties. Tomorrow, it's a shortened class period. The day's not shortened. It's just this class period. Okay? And what we want to do is do an activity that's similar to how we're going to explain that bottle that we just threw out to you. Okay? And say that again for everybody. Okay? Should be potassium iodide. Okay? I can never remember if there's one S or two S's in potassium. Okay, there's two. Magnesium's only got one. Okay, so potassium iodide. Okay? One of the things that would be worth your time, okay, is start correlating some of these elements to their symbols and their names, especially those in column 1, those in column 2, and the top row of the transition metals, which is your D block, and then also column 7, which is your halogens, where chlorine, fluorine, bromine, iodine are found, and then also nitrogen, oxygen, carbon. Those are fairly straightforward because a lot of them just start with the first letter of name of that element, like carbon and nitrogen and oxygen and fluorine. Okay, so if you have your table out, what is the symbol for potassium? What is the symbol for iodine? Okay, so what does it say on that bottle? It's really small writing. Does it have that same formula on that brown bottle? Does it say letter K and letter I somewhere on there? Okay. Well, one of the things I want you to look at on your table, okay, go ahead and get your table out, okay. When you look at the upper right-hand corner of iodine and upper right-hand corner of potassium, what does it say in those boxes? Does it have a plus sign maybe or minus sign? Okay, so which one has a positive sign? Which one? Okay, plus what? Okay, what does iodine have in its box besides 126, letter I, iodine, and it has a negative what? Okay, all along we've been talking about there's some confusion that these numbers are supposed to add up to 0. Okay, yes, I would agree. We can do something really, really simple here. If we do element number 3, okay, what is element number 3? Okay, so what is everything you can tell me about lithium? How many total electrons would it have to add up to 0? And why is 3 correct? Because how many positive charges are there? Okay, and then this number is important. Why? The number 3. It tells you the number of protons, which is which number. It's one of your vocab terms too, the atomic number. So when we say these have to add up to 0, what we mean is that the number and the letter have to coincide with this. Okay? Does that make sense? Okay? Because this is going to get to be a little more complex. You always write the positive ions first, and when you make a compound, the charges have to add up to 0. In this case, the atom, the positive charges and the negative charges have to add up to 0. Okay? Would you guess that, and this is just a guess, because again, we're not experts at looking at this periodic table. Could lithium and potassium have something in common? Where is it located on the periodic table? It is. And potassium's where? That's also in the S block. Are they in the same column or different columns? Potassium and lithium? Yeah. And one of the things I just usually make a habit, the last electron or electrons, whether it's an E or whether it's a 2, whether it's a 6, I just usually put a box around that. It's just always have, okay? So if we go to a little bit bigger now, okay, what element are we talking about now? And how do you know that? Because it's element 19 is potassium. Okay, again, follow your slide rule. The big number 1 tells you the first energy level, S block, which can hold how many? Okay. Go to your next slide down. Okay. And okay. Then what does the slide rule instruct you to do? Third energy level. And again, why did you know? That's right, but why did you know that? Because there's a big 3 in there. The big numbers tell you which energy level you're in. Okay? So 3s what? Okay? Then what? What's after 3s2? 3p6. Okay? So one of the things you can always do is we've got 6 here, and 12 gives you a total of what? 18. But we need how many? 19. So what does the slide rule tell you to do next, or instruct you? Go to the 4th energy level and do what? Okay. See, this has something in common with lithium. Since they're in the first column, they both have not just one electron in its outer energy level, but one valence electron. Electrons are those, or valence electrons are those found in the outermost energy level. That's what determines that element's reactivity. Okay? We've got 19 protons, 19 electrons. So the positive and negative charges add up to 0. Would we agree with that? Okay? Now we're going to really test ourselves out and do iodine, because you will be doing elements that big for your activity. So what is the atomic number for iodine? Okay? So again, follow your slide rule. Do you want one of your classmates to explain this? Because we've done that before. Do you want myself to continue, or one of your classmates that's comfortable with this? Asking for input. Okay, I will continue. Okay, so follow your slide rule. 1s, 2s what? Okay, now, then what? 3s2. Okay. 4s what? Okay. Then do we stay in the 4th energy level? No, we go back down to the 3rd energy level. Which block? The D block. And the D block has how many columns? Okay. Now, remember, we need to get 53 of those on the outside to match this with what we see on the inside. And at any time, you can always check to see where you're at. Right now, we're probably at 30. 2, 4, 6, 8. 18 and 12 gives you what? 30. So one of the things you can do, look at your table. Where is element number 30? I mean, what element is element 30? Zinc. So we're getting closer. So we left off with, okay, so 3D10. What's the next thing the slide rule instructs you to do? What comes after 3D10? 4P, okay, 4P6, okay. Then after 4P6, do we change energy levels? Yes, we do. And for those of you nodding your head, yes, how did you know that? Because the slide rule instructs you to do that, okay. So 5S what? Okay. Then what comes after 5S2? 4D what? Okay. So now we're getting closer. I bet we're leaving off with cadmium right now. Okay. So then once we've done 4D10, what does the slide rule tell you to do next? Okay? Now, in the P block only, just the P block, okay? Within this P block, what column is iodine in? Okay? And we're designating that by putting that 5 there. You can always add these together. Okay? 2, 4, 6, 8, 10. Simple math. I like that. 2 more, that's 20. Okay? So then, looks to me that we've got 18 and 23. Okay? So 3, 4, 53. That matches that number. So that's got to be right. You can always check your answer to see if they add up to one another. Okay. Do we remember how we had seen what happens to sodium and chlorine? We watched it last week. It forms salt. Okay? Do these two compounds have anything in common? What column is potassium in? We said it already. The first. What column is sodium in? The first. What column is iodine in? Okay, here's where it gets to be a little tricky. Okay, it's the 7th column. We don't count these columns here when we're saying it's either column 1, column 2, 3 through 8. Okay, that's just how the periodic table is used. This is why. Okay. Look at some of these elements like chromium, manganese, iron, cobalt. What do you notice about them for their charges? Look in the upper right-hand corner. Do they have just one charge only, like +1 only, +2 only? No, they've got multiple charges. That's why we skip over these. So when we say the column, it's either 1 all the way up to 8. Okay? It's very important that we know that. Do column 1, column 2, column 3, 4, 5, 6, 7, and 8. Okay, so what we see then is that is reflected here. This is in column 7. What column is chlorine in then? If it's in the same column as iodine, it must also have 7. Okay? So this has a charge of +1. This also has a charge of -1. So these two elements are highly, highly reactive. So according to the illustration, and we'll review that here shortly, okay, what happens to this electron? Do we remember that from the video last week? It actually leaves, okay, so that's empty, and that actually ends up over here, okay? So, how many positive charges are on the inside here? Because this is the atomic number, the number of protons. How many positive charges? 19. How many electrons are out here now? And what type of charge do electrons have? Positive or negative? They've got a negative charge. Add those two numbers together. Add these two numbers together. What type of 1? Plus 1. Right there it is. Okay? All right. So, when we do this, how many positive charges are in the nucleus for iodine? 53. Okay? So, if we add all these together, it had 53, but what did we do? We added one more, right? So now, if we add these two numbers together, what if there's 54 out here, and we add those two numbers together, what do we get? Okay, so if 53 plus negative 53 gives you 0, right? Is that? This would give you a negative 1. That's where that number comes from. Okay? Now, you've got to tell me if this is not making sense.
Does it just make it so that the whole energy level is full?
Yes, when this gets 8 electrons, remember when we were counting from left to right? Once this hits the number 8, it is chemically stable. Because when they looked at this periodic table, they actually had the periodic table, said, what about these noble gases? What is nobility? Everyone wants to be like the noble gases. They all want to be like this. They all want to have 8 in its outer energy level. Once it does that, it becomes extremely stable. And that's why when you look at that table, okay, a lot of those elements in column 8, like helium, neon, argon, krypton, in the upper right-hand corner, it has what type of number? 0, because they are extremely unreactive. They've got 8 electrons in there. They don't want to be with any other element. So, I have this as sleep. I don't want it to shut off. So, again, you've got to tell me, front row, we're understanding this. Okay? Second row. Third row. Okay? So, if you don't want to say, I don't get it in front of your classmates, I understand. Please, get in and talk to myself. I don't think I'm that mean. I'm Mr. Wagner, he's a lot meaner than I am. I don't know. You're not that mean, Mr. Wagner. We let you back in the building, so you must not be that bad. Go talk to Mr. Wagner. Come talk to myself. It's your responsibility to take that initiative. Okay? So, let's review that concept, okay, that they're illustrating here. The reason we are spending so much time on this, we want you to be successful when you take general chemistry, and it might not be such a thing to where it's not if you're going to take general chemistry, it could be when you take it. Maybe we shouldn't mix politics with education, but it's a big part of what goes on in peer. Do you talk about that in your college classes? What they're doing at the state level in peer that could affect education. There is a bill that's been proposed that the state of South Dakota may, then I'm not saying they will, they may require you to take the ACT test. It could become a requirement. Okay? I'm not making this bill. I'm not making you take this. Mr. Wagner would not be making you take this. Ms. Anderson would not, well, are you mean? No, you're not mean either, Ms. Anderson. Depends on the day. How's today then? Pretty good. Okay, so even Ms. Anderson's not going to make you take that test. The state of South Dakota does that. Okay, so this is just a quick review of that very same concept we just talked about, because I think it is so important for us to understand. I can't express that enough. Let me get this set. And it's going back to making that sodium chloride.
Which brings me to one of the most notorious electron hounds on the table. Oxygen.
Oh, what's too far?
O. 8 protons, 8 electrons. For it to get rid of that extra electron.
Okay.
Cut it quickly.
Ah.
You should see some soap. Alkaline metal. Like all the elements in this group, it's desperate to get rid of that extra electron.
So it just said these elements really, really want to get rid of this one electron. So since they're in column 1, how many valence electrons do they have? It's showing you that right here. Huh. Okay. Sorry. We're doing our best here. This was working earlier. This was working earlier, Mr. Wagner. It was. And why it's not now is beyond me. It is.
Can I go to the bathroom?
Yes. Okay, so why is this not working then?
You cut it quickly. I should...
Okay.
should see a silvery surface inside. Indeed, wow!
It slices like cheese, but it's actually a soft metal. Teo's offered to put on one of his favorite sodium demonstrations. What happens when the pure element dumps its outer electron in a violent altercation with ordinary water? He insists.
Well, we have no control, or at least I don't. So, let's see here. All right. You can just do this as a review then. All right. So, if we wanted to do a configuration, which is another aspect that you're going to be responsible for, okay? An electron configuration is just a linear illustration of all the electrons out here, okay? So we can keep this really, really short. We'll put this electron back in here because we're just going to do potassium, okay? Okay. Again, you can write all of these elements out if you wanted to, okay? In other words, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So if you add all of those exponents together, what do we get? 2 plus 2 plus 6 plus 2 plus 6 plus 1. Well, that's 10, that's 18, that's 19, right? Okay. Does anyone remember how to do a shortcut with this? Say that again. Not quite the exponent. Okay. If we were to do, okay, we'll remove this because we've got it illustrated here. If we do this, argon, 1s2, 2s2, 2p6, 3s2, 3p6. Everything that you see inside this box matches up with everything you see inside that box. Okay? Would you agree that this is the same? Okay? So what that means is we can take a really, really drastic shortcut here. And if we say we're going to start with argon, what is left over outside this box? Okay? So, potassium. Which period is potassium in? Remember, periods are horizontal that go like this. It's in the fourth period. What column is potassium in? This is the period. That's the column. Okay? How about we do that for iodine? Okay? In other words, we can't go up in number with noble gases. Okay? Because your noble gases have this, 10, 18, 36, 54, I don't know, is it 86? Is that radon? Okay. So, we can't use xenon here, but remember, we can't go up, but we can go down. What is element 36? Krypton. Okay. We're already up to number 36. Okay. What period, remember horizontal lines, what period is krypton in? The fourth period. Okay. So now that we've established that, look at your slide rule. So the fourth period and the P block are completely full. What comes after 4p6, according to your slide rule. Say that again. 5s2. Then what? Now this is where, look, follow your slide rule now. 4d10. Okay? And what comes after 4d10? 5p5. Okay? So 2 plus 10 plus 5 is 17. What happens when you add those two numbers together? 6 and 7 is what? 13. Carry your 1. So 4 plus 1. Same number we've got there. So that's got to be right. Okay? So configurations. We haven't spent a lot of time on them. If you had to pick, okay, between doing a Bohr model, which is this, or a configuration, which is this, which would you rather go, which is maybe more difficult? The Bohr model.
Wait, more difficult?
Yes. This?
Yeah.
Okay. And maybe it's just more difficult because we haven't spent enough time on it. Okay. Which is fine. Okay. So, pick any element in this 3D block. Remember, this is the period. And D block has vertical columns in it. 27. Okay. Is that cobalt? Okay. So, this is the element that we're doing. Okay. Which noble gas could we use? You can't go up in number, you have to go down.
18.
Okay. So, what is, when we say number 18, which element is that? Okay. What period is argon in? Okay. What block is argon in? Okay. It's in the P block. So that means that third energy level, P block, is full. Okay. So what comes after 3p6? Then what does the slide rule instruct you to do after that? Okay. It can hold 10. Okay. See, that's where, it's not that you're going to say 3d10 comes after that. But what column in the D block only is cobalt in? 7 plus 2 gives you 9. 9 and 18 gives you what? 27. So that's got to be right. Okay? Right? Right? Okay? Does anyone want to come up here and show the rest of the class that who has a really, really good understanding of this? Is it 1 student, 2 students, 3, 0? Okay. Do you want to do one more? Okay. So you can make it as simple or as complex as you want. You need to pick an element off of this table. 72. Okay. So then we pick element 72 is hafnium. Okay? Okay? So remember, you can't go up in numbers. We can't go all the way up to radon, but we can go down to what? which is element 54. So then what is the next thing that you do? What S2? Okay? 6S2. Okay? What comes after 6S2? Now, we're not making this up. You have this content on your slide rule. 4F14. Okay, so let's check to see once where we're at. Okay, so if this is 16, 16 and 54 gives you what? Gives you 70, right? Okay, which must mean what comes after 4F14? So 2 plus 14 plus 2 plus 54 equals what? 72. So that's got to be right. We can always double check that. 54 plus 16 and 2 more gives you 18. Add those two numbers together. So that's got to be right. Okay, and this works for any element on that table. Okay, so that's why we practice it. Okay, so we have a vocab quiz on Friday. You have your first assignment then on Friday. Hopefully we can get, I don't know, the overhead works. We can certainly use PowerPoint to give you lecture materials, but for some reason it's not, the video player is not working. Okay, so your vocab terms. Is there any questions over those that you might be missing? I think valence electron was one, but what is the most simplest way you could describe a valence electron? Here's one of them. Electrons where? In the outermost energy level. That is a valence electron. Okay? Any other terms that you may be missing or would... Sorry? Alkali metals? Alkali metals are those found in column 1. Okay? The reason we know that, when we talk about these are alkali batteries because they're made out of which metal? Lithium. Where's lithium at on the table? Column 1. If these are alkaline batteries, it would make sense that we're talking about the alkali metals. So alkali metals are those found in column 1. Okay? What else? Alkaline earth metals. Just move to its next door neighbor. Calcium's 1, beryllium is 1, magnesium is 1. So those are elements found in column 2. Alkaline earth metals. Anything else? Halogens are those found in column 7. Okay? So, for those of you who have a really, really good understanding, where is column 7 on that table? Give me elements found in column 7. That's 1. Okay, so astatine, that's at the very bottom. We really don't consider, because that's a metal. But you're not making that up. How did you know that? Because they're all, just count over to column 7. Okay? All right, so hopefully we're not too lost. But if you are, it is your responsibility. Please take that initiative to say, I need help with this. All right. We'll catch up to you next time.